Okay, now I think we should start. Okay, let's begin. Let's start our course. So last time I gave you some questions, okay, and I'm taking your exercise. I'm taking your assignment. Do not worry about that one, and do not. I would like to tell you once again. Do not. Okay, do not miss or do not fail. You have to submit your work. Okay, before the deadline. All right. So before the time finishes or before the time crosses, you have to submit your work. All right now. So let me share the screen. Now we shall study from the slide. Okay. All right. Let's begin. We learn unit and the data unit, and we also learned how to find out the fundamental units which are involved in derived units. Okay. Now let us start with mass. So as we are quite clear about mass, as I have already told you, mass is a constant quantity. Okay, mass is a fixed quantity. It is also called the amount of matter that is contained in a body. All right, the amount of matter that is contained in a body, that is called mass. Let me go here. So as I told you earlier, the amount, okay, the amount of matter, okay, do not talk, please. Please do not talk. Listen to me. Switch off the mic. So mass is a constant quantity. Mass is a constant quantity, all right? So it is constant. It does not, mass is a constant quantity. Okay, it is for the world. So let's say if we measure 1 kg mass in Nepal, and if we measure the same mass in America, then the 1 kg mass in Nepal, 1 kg mass is 1,000 gram, and in America 1,000 gram equals to 1 kg. The same thing. So that mass is a constant quantity. That means when places change, all right, when time change, but the mass do not change, all right. That's a mass is called the constant quantity. You can see the word there, constant. Let me magnify. So you can see the word there, constant. So mass is a constant quantity. So how it is measured? It is measured. It is measured by beam balance. Right, mass is usually measured by the device called beam balance. This balance is called taraju in Nepali. It is called taraju. Okay, in Nepali it is called taraju. And the SI unit, mass is kg. It is called kilogram. All right, mass is measured in kg. Okay, that mass quantity, it does not change with when the places does not change, and it is also called mass is also mass is also called the total amount of matter contained in a body. Let me magnify. You can see there, that later you can see. Let me make it bold. Mass is also called the total amount of matter contained in a body. So it is the total amount of matter that is contained in a body is called mass. For example, let me give you the example of water bottles. Let's say water bottles mass is 1 kg. What does it mean? Water bottles mass is 1 kg. What does it mean? Water bottles mass is 1 kg. What does it mean? Okay, the total amount of molecules, the total amount of substance, or the total amount of molecules that makes that object, or that makes that substance is called mass. So mass is measured by the device called beam balance. All right, mass is measured by the device called beam balance. Which microphone is on there? I can hear noise, okay, some kind of noise. Which mic is on there? If your mic is on, please make it off. Okay. Okay. Anyway, so the total amount of matter, the total amount of substance that makes the matter, that is called mass. So let me give the example of this pen. You can clearly see the pen here. So this pen is a little heavy. Okay, it has certain mass. All right. Why it is heavy? Why this bottle is heavy? You can see the bottle here. It contains water. Why this bottle is heavy? Why this mouse is heavy? Why this mobile phone is heavy? Why this book is heavy? These objects are heavy because they contain matter, isn't it? Whatever the substances are, okay, these substances are made by the molecules. Okay, all the matter, they are made by the molecules, and each and every single molecule has certain mass. All right, and when all these molecules are, when masses of all molecules are added, then the the weight, or you can say the heaviness of that body increases. That's right. The amount of matter that is contained in a body, that is called mass. Mass is measured by the device called beam balance, or in Nepal it is called tarazu. All right. And mass is a constant quantity. That means when places are changed, when temperature changes, right? Whatever in odd conditions, all right? Whatever the condition is, when there is high temperature, when there is low temperature, when places are changed, that doesn't matter. Okay, mass is a constant quantity. When places are changed, mass does not change. All right. Let's say in Nepal, you put kg of in Nepal, 1 kg of sugar equals to 1,000 gram. And when you take the kg of sugar in America, and when you measure that sugar, then again you will find as 1,000 gram. That means when places are changed, all right, mass do not change. So that's why I told that mass is a constant quantity. All right. Now let me share the screen once again. Now let me go to the screen once again. Look on the screen, please. So now let us study about the 1 standard kilogram or 1 kg mass. What does 1 kg mass mean? 1 kg mass means what? So you can see the definition there. 1 standard kilogram mass is defined as the mass of platinum iridium cylinder. Okay, it is the mass of a special cylinder which is made up of iridium, that is one kind of element. Platinum, you might have heard the word platinum. All right, platinum is one kind of element. So 1 standard kg mass is defined as the mass of platinum iridium cylinder having equal diameter and height, having equal diameter and height, kept at 0 degree centigrade, 0 degree Celsius at International Bureau of Weights and Measure in France. So this is special block. This block is called 1 standard kg. All right. So 1 standard kilogram mass is defined as the mass of iridium platinum cylinder or iridium platinum rod having equal diameter, and height, whose diameter and height are equal, and they are preserved. They are preserved in the vault. They are kept in the special vault. Okay, in locker you can see vault means one kind of locker. Okay, all right. So that special cylinder is kept in the vault, which is kept at 0 degree centigrade. And where does that vault lie? That vault or that you can say or that special compartment has been put in France. Okay, all right. So that is called 1 standard kg. And you can see the mathematically 1000 milligram equals to 1 gram, 1000 gram equals to 1 kg, and 1000 kg equals to 1 ton, and even 100 kilogram equals to 1 quintal. So this is 1 kg mass. Let me show you one figure. Let me share you one figure. Okay, so you can see here. So this is 1 standard kg. This is 1 standard kg. Okay, this block is 1 standard kg. So you can see here. This is its diameter. This part, this is called diameter, and this one is called its height. Its diameter and height are equal. So this is one kind of device, one kind of block whose diameter, let's say this one is center. This one, you can see the arrowhead there. This one is center, and the straight line which runs through the center called diameter. All right, and this one is called height. So this is the special cylinder whose diameter and height are equal. And this cylinder is kept in France at 0 degree centigrade. Okay, this is called 1 standard kg. All right, so you can see that once again, 1 standard kg is defined as the mass of iridium platinum cylinder, having equal diameter and height, let's say this is the cylinder. Okay, let's say this is the cylinder book. Let's take this book as a cylinder. So this is diameter. This here, upper part, the straight line. This is diameter from here to here, from here to here, from one end to other end to center. Let's say diameter is 4 centimeter. Height is also 4 centimeter. Height 4 meter, diameter 4 centimeter. So this is special cylinder having diameter 4 centimeter, height 4 centimeter, and which is kept in the International Bureau of Weights and Measure 0 degree centigrade. This is special block. This is special block. This is special cylinder is called 1 kg. mass. All right, this is defined as the mass of iridium platinum cylinder, okay, which is kept at 0 degree centigrade, not at 1 degree centigrade, not -1 degree centigrade, not 2, not 20 degree centigrade, only 0 degree centigrade, okay, all right, at a special temperature, and that is kept, that is safely protected in the vault, okay, in one special compartment, one chamber, and that chamber lies in France, okay, all right. So this, the mass of that block, the mass of that special block is known as 1 standard kilogram. Alright, and we also know that 1 kilogram equals to 1000 gram, 1 kilogram equals to 1000 gram, 1 gram equals to 1000 milligram, as I've already told you. Okay, you saw in the slide, earlier slide, and 1000 kilogram equals to 1 quintal, and sorry, 1000 kilogram equals to 1 ton, and 100 kilogram equals to 1 kg. See, you can see the picture. This is the picture of 1 standard kg, right? 1 kg block, 1 kg mass. So in examination, if question asks what is 1 kg, then you will have to say 1 kg. The 1 kg mass is defined as the mass of, the mass of 1 kg mass is defined as the mass of iridium platinum cylinder. You can see here 1 standard kg or 1 standard kilogram mass is defined as the mass of platinum. See there, 1 standard kg is the 1 standard kilogram mass is defined as the mass of platinum iridium cylinder having equal diameter. Okay, kept at 0 degree centigrade or 0 degree Celsius at International Bureau of Weights and Measure in France. So these are the numerical value. Please memorize it. Okay. Now, so this is all about 1 kg mass. Now let's study about the weight. Okay, so what is weight? What is weight? Weight भनेको के हो? All right, so what is weight? And you know what? Weight and mass, they are totally different. All right. So if someone asks you what is your weight, then that is incorrect. So someone should ask what is your body mass. So you say my body mass is 45 kilogram or 45 kg. I am 50 kg or I am 55 kg, whatever. Okay. So that's a mass and weight, they are totally different. All right, now we are going to learn about weight. So let me give you one example. Let's say it is a pen. All right, so I'm holding a pen, and what happens when I release the pen? When I leave the pen, it falls down. Okay, when I leave the pen, it falls down. All right, so this is the pen, I'm holding the pen, and when I release, when I leave, then it falls down. Why does it fall down? Okay, not only pen, everything that falls down. All right, while you are playing a cricket ball, you throw that cricket ball up to the certain height, and after some time again it comes back. Why does it happen? Why it doesn't go up? Why it returns back? So this is all, this is due to the pulling force of the earth. Okay, the earth has the capacity of pulling everything towards its center, right? Earth has the capacity of pulling everything towards its center. All right, so that pulling force, the pulling force of the earth is called weight, or you can say the weight of the body. All right, the pulling force or the force with which earth or other planets, not only earth, all the planets have pulling force. Okay, moon is not a planet, it is a satellite, but still it has a pulling force. Jupiter has pulling force, earth has pulling force, each and every planets, all the planets have pulling force. All right, so the pulling force of the earth is called weight, or the force with which everything that is attracted towards the center of the earth. All right, the force due to which every object falls down, or every object that is attracted towards the center of the earth. That is special force, that pulling force of the earth is called weight of the body, or you can see gravity or weight of the body. All right, now you can see, you can, let me share slide once again. See there, when a ball is thrown upwards, let me begin with the example. When a ball is thrown upwards from the earth's surface, it returns back towards the earth's surface because of gravity. Let's say there is a ball, and when you throw that ball up to a certain height, and after some time again it comes down, again it falls down. Why does it happen? So this is because of gravity. All right, hence the force with which a planet or the earth attracts a body towards its center is called the weight of the body. So weight of the body is the force exerted by the planet or the earth not only Earth. Earth is also one kind of planet. There are many other planets. Okay, there are 8 planets, right? And all these planets have attracting pulling force. With this pulling force, the pulling force of the Earth, that is called weight of the body. So hence, the force with which a planet or the Earth attracts a body towards its center is called the weight of that body. Right now, all right. So the weight, the SI unit of weight is Newton. Weight means a kind of force, so it is measured in terms of Newton, and it is a derived unit. You can see there, weight or force is a derived unit. There is one formula. Weight of the body that is given by the formula weight of the body equals to mass into mass, that is noted by m, into acceleration due to gravity. All right, weight of the body, that is weight of the body, weight of the body that is measured. This is the formula to calculate weight. Okay, weight of the body, weight of the body that is noted by W. Weight of the body equals to mass, that is noted by small letter m, into, so that's why you can write the W equals to m into g. So this is the formula to calculate weight of the body. Weight of the body equals to W, weight of the body that is noted by W. All right, W equals to m into g. The SI weight is Newton, that is noted by capital letter M. So weight of the body, that is given by the formula m into g. M stands for mass of the body, and g stands for acceleration due to gravity. And write one note there. Okay, note. So the value of g on Earth is 9.8 meter per second square. All right. So the value of g, small g, that is acceleration due to gravity. All right, so that is on the Earth. Okay, the value of g on the Earth, the value of g on the Earth, that is 9.8 meter per second square. All right, the value of g on the Earth is 9.8 meter per second square. Okay, the value, so the value of g, that is varies from place to place. Okay, the value of g varies from place to place. Hence weight also varies. Right, you can see here, this is the important note. As I told you earlier, mass is a constant quantity, but weight is not a constant quantity. Weight is a variable quantity. All right, you can write here variable, variable quantity. Variable means that is not fixed. So weight is a variable quantity. Why weight is called the variable quantity? You can see the answer is there. The value of g varies from place to place. Here weight also varies from place to place because the value of g is not constant. You can see their weight can be calculated by the formula m into g. Mass is constant, mass is constant, mass does not change, isn't it? But weight g changes. And when the value of g changes, when g changes, weight also changes. So weight is not a constant quantity, but mass is a constant quantity. So listen once again, weight is a force, weight is attracting, or you can say weight is attraction. Weight is the force with which a planet or the earth. Okay, weight is a force with the help of which a planet or the earth attracts a body towards its center. When I leave this bottle, it falls down, isn't it? Why it falls down? Because this bottle is attracted by the earth. Earth has pulling. The force of the certain height up and down, isn't it? This is because the pulling force of the earth is called the weight of the body, isn't it? And weight of the body, that is measured by spring balance. Spring balance. You might have seen spring balance, all right? The spring balance is used to measure the weight. This is spring balance. I'll show you the picture a little later. Weight is measured by spring balance, but mass is measured by beam balance. Weight is a constant quantity, weight is a variable quantity, but mass is a constant quantity, right? Isn't it? And the unit of mass is kilogram, whereas the unit of weight is Newton. So these are the major differences between mass and weight. And weight is calculated by the formula m into g, isn't it? Weight is calculated by the formula m into g. M stands for mass of the body, and G stands for acceleration due to gravity. So if we stand on the earth, then we'll have to take gravity of the earth. If we stand on the moon, then we'll have to take gravity of the moon. If we stand on Jupiter, then we'll have to take the gravity of Jupiter. If we stand on Mars, then we'll have to take gravity of Mars. G stands for acceleration due to gravity. That's right. Since acceleration due to gravity is not a constant quantity, it varies from place to place. Even on the Earth, G is variable. Right? If you go to Mount Everest, okay, if you go to Mount Everest, the G it has another it has certain G, and if you go to other place, it has certain G. That means the value of G is not 9.8 everywhere on the Earth. Okay, it is the average value. Okay, so if you go to the pole, the value of G increases, and if you go to the equator, the value of G decreases. Right? So G is not a constant quantity, so due to which due to which weight is also not a constant quantity. Right? Because weight is calculated by the formula m into g, and mass is a constant quantity. Mass does not change. What changes? Mass does not change, but what changes? G changes, and when G changes, the weight also changes, isn't it? So let me give you one example. Let's solve one numerical, okay? And you'll be more clear. So this is the question. So you can see that. Okay, see here. So see the question there. The mass of a stone is 10 kg. All right. There is a stone whose mass is 10 kg. And you are supposed to calculate the weight of that stone on the moon. Now calculate its weight on the moon, whose acceleration due to gravity is 6.667. Okay, you can write 6.67 meters per second. So that is the question. So how do we do it? So write the given. First write given. What is given there? Mass. What is the value of mass there? It's 10 kg. And secondly, acceleration due to gravity. It is noted by small letter G. What is its value? 1.67 meter per second square. Weight that is noted by small letter W equals to what? So this is the question. So we know W equals to, we know one formula. I give you one formula, M into G. Okay, now right there equals to, what is the value of M there? 10 into, what is the value of G there? 1.67. So what answer equals to? Is 16.7 Newton. So this is therefore weight. All right, now weight equals to 16. So please memorize the formula. Weight equals to m into g. All right. So that is the question. So that is the solution as well. Now let me go to the screen once again. So alright, students. So I hope you are clear about that one. So let me repeat for the last one once again. So what you learned today, we learned 1 kg mass today, isn't it? Right. So 1 kg mass is defined as the cylinder whose diameter and height are equal, and that is made up of iridium and platinum, which is kept in the vault of weights and measures in France at 0 degrees centigrade. That is a block. It's called 1 kg. All right, and the mass is measured in terms of kg. And we also learned about weight. Weight is a force, right? The pulling force of the earth. Or weight is a force due to which a planet or the earth pulls a body towards its center. For example, when I leave this bottle, it falls down due to the pulling force of the earth. Okay, the pulling force of the earth upon this body. The pulling force of the earth upon this body is called weight of this body, isn't it? The pulling force of earth upon this body is called the weight of this body. And weight is a variable quantity. That means mass is a constant quantity. It does not change when places are changed, but weight changes when places are changed. All right. So weight is a variable quantity, and weight is given by the formula W equals to m into g. Right, m, that stands for mass of the body. G, that stands for acceleration due to gravity, that is small, that is noted by small letter g, and its value is 9.8 meter per second square on the earth. All right, so the different planets have different value of z. Moon has different value, earth has different value, Jupiter has different value, Mars has different value. All right, so this is how we calculate weight. So I hope you people are clear. Gaurav, will you please switch on your mic?
Yes, sir.
Are you clear about weight?
Yes, sir.
What is weight? Tell me, quick. We don't have.
The force of Earth which brings any
No, don't
substance
say Earth.
to
Don't say Earth. It is not only Earth, planet you should say. Okay? The attracting or pulling force of the planet
the
you should say.
pulling
Okay?
force of planets which bring any object to